All right, and I will post this later on as well. Okay, so we're looking at number one, tangent x over secant squared x. Now, a couple things. Number one, this is what we mean by a monomial. There's a single term in the denominator. Now, here's something else you can use to guide you. What you're trying to get the left-hand side equal to on the right side has two different terms in it. That tells you that you want to take the left-hand side and break it down into two terms. And how we break it down, and it can be in the numerator, it can be in the denominator. We'll go through one momentarily where it's in the denominator. And what you do is you write two different fractions, each of which with a denominator secant x. Because secant times secant is secant squared. Okay? Now, if you have two things in the numerator, you write each. But in this one, we only have one. So we have tangent, and we don't have anything else. Well, that means the other numerator's got to be what? 1. All right? Now, here's other things you use as you go along. 1 over secant x is cosine x by reciprocal identities. You hopefully will recognize that that means the cosine x is already taken care of. So we don't have to worry about that anymore. Make sense? So, that means we only have to worry about the left-hand side. I'm going to rewrite it as a division problem. Tangent x divided by secant x. That's what that becomes. Alright, you good? Whenever you have a division problem, feel free to rewrite it as a multiplication and then just switch the trig function to its inverse. The inverse of secant is cosine. Alright, it's completely legitimate. Then, this falls under the strategy we introduced on Monday and is on that sheet. When all else fails, rewrite it in terms of sine and cosine. Tangent is sine x over cosine x. Cosine x over 1. What then do the cosine x's do to each other? Cancel out. Good. And we're left with sine x, and then we bring down the what? Cosine x equals sine x cosine x. And you're done. Yes, ma'am?
Did you get it wrong if you wrote it the other way?
What's the other way?
Or if you put cosine first?
If you put the what?
Cosine first.
No.
Like cosine x.
Yep, it's fine. Because multiplication is commutative, so you're fine. Alright. Now, number 2 is a special case. Okay, number 2 is a special case, and this is in there. This is the only time you're going to factor a fraction where the degree is 2. Because you look at your numerator and denominator, and there is a specific Pythagorean relationship between sine squared and cosine squared. It's the only time you factor. Otherwise, you're going to work with the conjugate. So what you do is you rewrite sine squared as 1 minus cosine squared x over 1 minus cosine x. Alright? That's the only time you do this. Then you're going to rewrite the numerator as a factored form. It's a difference of 2 squares. We'll talk about that in a bit before we walk out today. So 1 minus cosine squared becomes 1 plus cosine. 1 minus cosine all over 1 minus cosine. What do the 1 minus cosine x's do to each other? Cancel out. Leaving you with 1 plus cosine x. That seems to be pretty simplified. So I'm going to leave that alone. So that means I'm going to go over to the right-hand side. That is over a monomial, so I'm going to divide through. In other words, I'm going to take both terms, secant x and 1, and put them over the same denominator. Well, you should know by now, when you have a rational expression where the numerator and denominator are exactly the same, that will simplify to what? 1. And then secant x, 1 over secant x, what is the inverse? Cosine x. And then your two sides are what? Exactly the same. So if you get to a point when you're working with one side and you're like, man, that's pretty simplified. And what I mean by simplified is you got a number and you only have sines and cosines and there's not really anything else you can do, then you will jump over to the other side. Okay? But again, if you have a Pythagorean relationship between the numerator and denominator, that's when you factor. Now, if you look at number 3, there is no Pythagorean relationship. That tells you you're going to multiply by the conjugate. So that means I'm going to take my original left-hand side, which is 1 over cosecant x minus 1, and I'm going to multiply by cosecant x plus 1. I'm going to multiply by the conjugate. That's going to give me cosecant x plus 1, because multiplying by 1 stays exactly the same, over cosecant squared x minus 1. The reason I do that is because more than likely that's going to give you a Pythagorean identity on the bottom. Cosecant squared x minus 1 is equivalent to cotangent squared x. The reason I do that is now I can take my expression and write each one over the denominator. In other words, I can take the first part, which is cosecant x plus 1. So I take the cosecant x, put that over cotangent squared x, and I take the 1 and I put that over cotangent squared x. Okay? Good? At that point, I would take a look at my right-hand side and simplify that. You're going to simplify that by doing the distributive law. Tangent times secant is just that, tangent x secant x. We'll work on that in a second. Plus tangent squared x. Why would you do that? Because I see tangent x is on the right and I see cotangent on the left. Reciprocal works for squared as well. Reciprocal of cotangent is tangent. So that, ladies and gentlemen, becomes tangent squared x. Everybody good with that? So that tangent squared x and that tangent squared x match up. Which means now I only have to focus on the left-hand side. I rewrite that as division. Cosecant x divided by cotangent x equals cosecant x times tangent x then I rewrite everything in terms of sine and cosine. Cosecant x is 1 over sine x. Tangent x is sine x over cosine x. What do the sine x's do to each other? Cancel that. Giving you 1 over cosine x. Which is what? Secant x. Hold on, I gotta check something. Quiz review. Yep, that works. One over sine x times tangent squared x. Oh, this one was squared. Sorry. This one's squared. Alright, so that becomes the tangent x secant x. Sorry. And then you're exactly the same. we look down at number 4, what's 1 over cosine x equivalent to? In other words, what's the reciprocal cosine? Secant. Are those two now exactly the same? Yep. So now I take sine x, right, is divided by tangent x. Sine x times cosine x over sine x. Dividing by tangent x is the same thing as multiplying by cotangent. Cotangent is cosine over sine. What do the sines do to each other? Cancel out, leaving you with cosine x plus secant x. And then your two expressions are exactly the same, and you're done. And again, if you added secant x plus cosine x, you'd be fine as well. Alright? A little bit of factoring. If you look on the left-hand side, what do both terms have on the left-hand side? Secant squared x. I'm going to factor that out. When I factor out the only term, I have 1. Everybody good with that? When I factor out the secant squared, they cancel out. I got 1 minus sine squared x. 1 minus sine squared x is a form of the Pythagorean identity. That is equivalent to cosine squared x. Are secant and cosine inverses of each other? So when they're squared, they're still inverses of each other. You end up with 1 equals 1. And you're done. Good? Alright, number 6. Cosine x over cotangent squared x. Cosine x over cotangent squared x. Again, this is squared. So I'm going to rewrite it as 2 fractions. First one's going to be cosine x over cotangent x. The second one is going to be 1 over cotangent x. Did we get that? What is 1 over cotangent x equivalent to? Tangent x. Does that match up with that?